Our next speaker will be Ofir. Ofir is also a postdoc here at PLI and has been around here since last year as well. We're working on tough benchmarks for language models as well as in solutions. Ofir previously completed his PhD at UW last time. So let's welcome Ofir.
I made like a 3-bunch 3-agent talk, but now I'm realizing that we've only done 3 bunches 3 agents, so maybe we can focus on like the intro part. Okay, so language models are very useful, but I think they could be more useful. And when I started doing language modeling research like 9 years ago, or machine learning research, there was like this very precise algorithm that everybody followed to do research, or almost everyone. People would choose a task, and like 9 years ago, this would be, it was like name entity recognition, part of speech tagging, I don't know, translation, news topic classification. So you choose a task, and then every task, there would be like 3 benchmarks that everybody knew for that task. And you'd pick one of them, and then you just try to optimize it. But this method definitely doesn't work anymore because all the benchmarks are really saturated, right? Like in almost all the benchmarks, the best score for like GPT-4 or whatever it's 90%. And the last 10% is trash. Like there's nothing interesting to do in there. It's usually like annotator issues. So 90%, that's it. We're done with that. And so I think we need to go back to the drawing board because we can't, all the benchmarks are saturated. And I don't think it's really interesting to just take an existing task and think of a new benchmark for it because it'll also be saturated. So this new approach that I think would be useful to the world is to think about how language models could benefit humans in the future. Forget about all the existing tasks. Forget about tasks. Just think about how humans could be more productive in the future. And then design a benchmark that formalizes this topic or thought that you're having. And then once you have a benchmark, it's actually pretty easy to build a system that does well, or try to start iterating. So I think the kind of harder thing is to think of a really good benchmark. Once you have a good benchmark, building systems for it, it's not easy, but it's when you're iterating against something, it's very kind of becomes clear how to work. So I spent a lot of time now thinking about how language models could be more useful for us. I try to think about how language models could be useful for any human, like a lawyer, or a doctor, or an architect, or an engineer. But I mostly understand like engineering and science. So as you'll see, the kind of ideas that I've been thinking about are in that domain. I also think it's a really important domain to work on. If you could automate programming, or if you could automate like 10 or 20 or 30% of programming, that would be of huge economic value. If you could help researchers, that would have a lot of economic value. So the 2 domains I've been thinking about are automated programming and what I call automated data collection and synthesis, or automated research. When I say automated research, as you'll see, I don't only mean scientific research, I also mean like personal research. Like we have this data set where the questions are things like, what restaurants near my house have vegan entrees that are gluten-free for under $20 in Copenhagen right now, right? So that's like a question that I consider research. It's not scientific research, but I have a lot of dietary restrictions, so I gotta get this. I can't eat gluten, I can't eat soy, I can't eat all kinds of fruits that have a lot of sugar in them, so I gotta get progress on this domain, so.
So it's more like search. Just that search is now currently defined as Google search.
Sure, you could call it search, but I feel like Google search is very good at finding things that explicitly mention what you're searching.
No, that's the way it works.
Yeah. So the way it works now is kind of weird.
Next generation.
Yeah, next generation search. Sure. I think Perplexity.ai is doing exactly this type of thing. Okay, so we have step 1, right? We have these 2 kind of, I mean, in the second one, I kind of gave you more meat, but automated programming, when I say the word automated programming, that's not a benchmark, that's just an idea. So the question is, how do you build a benchmark for an idea that you have? And so let's spend most of my time on these next two slides because this is stuff that I haven't talked to Kristen about before. I don't think I've talked about this. Anyways, have I talked about this? Okay. You'll enjoy it again. So when I build a benchmark, I try to think about three main things that I want all of my benchmarks to have. And the first thing I think about is I want my benchmark to be natural. I want my questions to be natural questions that a real human would ask in their day-to-day job or life. And so I really dislike benchmarks that have, all this common sense bullshit about Ofir threw an egg at Alex. Is Alex happy or mad or sad or neutral? Right? Like nobody's waking up saying, oh my God, if I throw an egg at Alex, I wonder what he'll think about me. Let's ask ChatGPT. I really need to spend $2 billion to train a language model. Right? So think of things that are natural and challenging. These questions were totally okay when our language models were very good in like the GPT 1 and 2 eras, when they couldn't really do anything useful. It was totally fine to ask them, what's 11 times 12? But now that we're entering this kind of new GPT-4 era, we should try to really challenge them and do useful things. So yeah, think about natural. If you have a hard time understanding the definition of natural, I think that useful is kind of contained in naturalness. So when I think of benchmarks, I want to think about a benchmark that if I build and I have a system that works well on that benchmark, that will be useful to me. So when we built SweBench, right, you can automate bug resolution on GitHub. That's super useful. And you'll see that I have a few other benchmarks where it's really obvious that if we could build a system that does well on this, it would be useful. This wouldn't only be, can I throw an egg at Alex? Like this wouldn't only be just for play, it would be useful. The second thing is you have to make a benchmark that's challenging. And this is really obvious, but some people don't understand it. Like I just saw a benchmark from some really famous people, and right at submission, their accuracy was like 75%. Their baseline accuracy was 75%. That's not exciting. Like 75%, it feels pretty solid. You got to get people, you got to make them kind of, hit them with like the 2% part of that. Like make them feel like it's a.
What were the open ones?
For the 75 one? Probably not super good, but open models aren't that, like Llama 3.1 405B is pretty good.
No, not 405. Llama 3, Llama 8.
Sure, but I still feel like if GPT-4 can do it, it doesn't, 75% feels like next time OpenAI trains a model, it's just going to be totally soft. I think you really have to be, like when we put SweBench out, it was 2% accuracy for the best model. So I really think you have to be under 20.
But it's like 30 plus now.
No, on light it's 40%, but on the original, the big original SweBench, it's 22%. So yeah, you got to be challenging. 30% is good. Don't be too scary. Like don't go like 0.002%. That's really scary. Or have a plan. Like when we put SweBench out, it was 2%. But we all knew that we would then build the agent, and I was kind of really hoping that the agent would get 6%. And I was telling everybody, if we get 10%, I'll buy everybody gelato. And I was like, if we show that at Princeton we can go from 2% to 6%, then everybody will be really like, invigorated, and we'll start doing research on this as well. And then what ended up happening is we got to 10%, and the startup launched and used SweBench, and they went super viral. And then everybody had all this motivation. So yeah, like humans have emotions. And when we first launched SweBench at 2%, nobody wanted to work on it because they just thought it was too hard. So you gotta, I don't know, strategize things. But yeah, make sure it's challenging. Don't launch at 80%. I don't think it's a smart thing to do. And the last thing is easy to automatically validate. So I've been doing deep learning for 8.5 years, I think. And the only thing, or one of the only things that stayed true throughout this entire time is iteration. I think the person who wins is the person who iterates the most. And you iterate by training a model, running a model, getting a number, kind of thinking for a second, and then training another model, and then thinking, training another model. But you gotta hit the with metal. Like you gotta iterate. Deep learning is not a great subject if you like sitting in front of a whiteboard and like theorizing for. It's not. The only reality is what happens when you hit the metal and you get a number. And so when I think of a benchmark, I want something that I can give me a number really, really quickly. I want to be able to kind of attempt to build a system, make an attempt at getting a score in this benchmark, and then get a number. And so that's what I mean by easy to automatically validate. So for example, one thing that I'm really, really interested in is I've talked to a bunch of ER doctors, and they write all these notes when you're in the ER. And after 8 hours, their shift changes, and they have to summarize every patient's notes. And if you could get ChatGPT to do that, that would save them a lot of time. So summarization, I think, is a really, really important task, especially in this medical domain. But the problem with summarization is that there's basically no way to compare a given. If I have a correct target summary, and then Danchi gives me her summary, there's all these heuristics and like approximations, but none of them are really perfect or even great, right? There's multiple ways to totally correctly summarize something, but we're using totally different words. So summarization is not automatically validatable. So when I build a benchmark, I really try to think about something that's automatically validatable. So for example, if you have a multiple choice question, right, and the answer is B or whatever, that's very easy to automatically validate. So yeah, so I always try to think about things that are easy to automatically validate. And that's why I haven't worked on summarization yet. And then people like asking what I think about like using GPT as a judge, but I don't like that stuff. I feel like you can either use it only as a judge to judge some non-AI system, or only as an AI system and use a non-AI judge. I think if you use GPT both to judge and to do, it's weird. And people have shown that it kind of prefers GPT-4 outputs over human outputs. So it doesn't even work that well. So yeah, so I think about having a validation function that's like deterministic, non-AI, and it's very easy about. Okay.
Somewhat in contrary with the natural, because putting down multiple choice is very easy to validate, but it's less natural. Like,
Yeah, it's one of my points. I mean, it's doing these three things together is very, very hard. That's why there aren't a lot of good benchmarks. Oh, and my favorite one, this is a super hard to achieve, but hard to leak into the training data. So basically what happens when you put a data set out is that everybody crawls it, and then it's in the training data. People don't even do it intentionally. And I think like, even when you really try to clean your data, things just end up in your data that you didn't want to be there. I don't think people are being bad actors. It's just really hard to clean a lot of terabytes of data. And so a bonus factor is making a data set that's hard to leak into the training. That means that even if I took the file that describes the entire data set and I put it in the training data for GPT-5, it still wouldn't help the model do well on the data set. It seems impossible to do, but I'll show you how we did it.
What do you think is a current data set
That does this?
that cannot, or like there's some.
So human eval is the first data set that I think that achieved this really well. So human eval, they ask you to program something, and then they validate your question using unit tests.
Mm-hmm.
So even if the unit tests leak into the training data, it's not the code that does well in those unit tests. So you can't really, you're not getting too much from looking at the tests.
They don't provide a solution.
They don't provide a solution.
No, but you can easily fine-tune the model to just make sure the unit tests on.
Yeah, so you could, if maybe in like GPT-8, when they become really intelligent, they'll be able to like build a function that will, if input 7, return 9. If input maybe, but it would be very easy to spot like, that they're cheating. And that we haven't seen them doing that yet. So yeah, then I have this rant about naturalness. So it's sometimes very easy to identify that something is not natural. I think multiple choice is a very, very unnatural setting. I've never gone to the doctor and said, doctor, my elbow hurts. And it's happening because of one of the 4 following up, right? It's not very natural. And this is a finer point. So the questions are made up and not taken from real tasks. So imagine you're working at Google and your boss asks you to find questions that are hard to answer. There's two things you could do. You could just sit in a room by yourself and try to think of questions and then, Google them and see if the results are kind of bad. Or you could go into the Google logs and get all the queries from the past week where the user spent more than 20 minutes on the, search engine result page and didn't click out to anything. And you could infer from that those were hard to answer questions. And the second choice is much, much better because there's also papers, I need to find, there's like a canonical citation for this, but when people are forced to think of questions, they don't actually think of very natural. They kind of make up questions that are bad or that assume that the question could only be asked if the question asker knows the answer. Like, it's just unnatural. So it's much better to tap a natural source for your question. And this is also good for us because it means that we don't have to pay like humans to do stuff. We should try to, go into the wild and try to naturally find naturally occurring questions. So yeah, naturalness is hard. It's also very hard to do something that's challenging and easy to automatically validate. Usually when I think of challenging tasks, I think of tasks that are multiple tokens long. Like, for example, programming something that's really complex. It's a lot of tokens. Or summarizing is very hard, or writing a story. But easy to automatically validate. The longer your output is, the harder it is to automatically validate. Right? Multiple choice, there's only one correct answer. But if your answer is a sentence, there's lots of different sentences in the English language that mean the same thing, or if it's a paragraph or more. So yeah, it's very hard to build a dataset. Okay, who knows what sweet lunch is? Okay, so for the two people in the audience that don't know, I'll quickly go over it. Okay, so yeah, so I wanted to kind of think about this automated programming thing. So software engineering involves kind of two main things, either fixing bugs or developing features, and we're going to focus on fixing bugs. It's a very formalized process. Somebody makes a bug report, and then you wait for 2 months, and then somebody really nice makes a PR. And in the PR, they have two things. They have the thing that solved the bug, and they have the test. And what we did with Sweetbench is we just have these pairs. I'm going to skip over a bunch of slides here. We have these pairs of bug reports, and we give you the entire repo at a certain time when the bug was reported, and we have a test, and you submit a patch that attempts to solve the bug, and we run the tests, and if they run, we give you a point. That's Sweetbench. Yeah, that's it. I'm not going to talk too much about Sweetbench because you guys already know about Sweetbench. Yeah, so I really like this Sweetbench approach. It's been doing kind of okay. People have been participating. But I kind of wanted to go further. And so this is like a year ago, I was talking to my friend in physics, and I was asking her if she uses ChatGPT. And she told me, no, ChatGPT really is bad. So she's like a physics PhD, but what she actually does is she programs. She's doing like theoretical physics, but like she's just programming a lot of things. And I was like, oh, do you use ChatGPT to help you program? Because I use it all the time. And she was like, no, it really, really sucks at physical stuff. And I was like, interesting. And then I got invited because How, the last author, was my friend from the PhD, and now he's a professor at UIC. There's a group of people who have a lot of physics knowledge, and they decided to make like the Sweetbench for physics. It's called Psycode. It's got, oh, and Killian is also on the paper. It's got 338 programming challenges written by PhDs or above in physics, math, material science, biology, and chemistry. And I think 10% of the questions are based on Nobel winning research. And it's really like, we can read this, but I don't understand anything here. Generate an array of Chern numbers for the Haldane model and a hexagonal lattice by sweeping the following parameters. This, that, and other thing. This is super tough stuff. And we gave it to GPT-4, and it gets 4% of these questions correct. And yeah, it's really cool because doing better on this benchmark is going to make it better for my friend who's a physicist. Yes.
How does it do on the natural criteria? Because here you got people to write questions. You just said getting people to write questions.
Yeah, you're right. You're right. The questions are based on things from actual papers, so I think that's pretty natural.
So each of these was.
Yeah,
was
this is,
used.
yeah. Each of these things was used in the paper. It's not just kind of totally made up. It's based on an actual paper.
But then you would imagine that that's in the training data.
Exactly. Wait 1 second. What?
The same question, actually.
Oh, okay, yeah. So Killian probably understands more, but none of these people upload their code to GitHub. Especially because like a lot of this is from like more than 10 years ago, but none of this is on GitHub. And also, even if somebody, none of it is online, they also search for it. But also, even if somebody, let's say, did write it in like C like 20 years ago, we wrote everything from scratch in Python. So we wrote all the solutions in Python, and then we wrote all the unit tests in Python. The unit tests are our unit tests, and some of them check for like specific numbers that we generate. Like we generate like these random inputs, and we know what the output is. And so we're testing it on things that have never been seen before online. And also, one of the really cool things we did for this data set is I told them to not ever send anybody the answer text, the Python solutions. So Killian has it and a few other people have it, but nobody else has it. We're not posting it online. And so even if this entire data set leaks into the GPT-5 training set, it can't really do better. It only has the unit test. It doesn't have the actual process.
Just
Yeah,
reminding you have 2 minutes left.
Oh, I have 2 minutes left. We'll have enough time. So yeah, so the soda was 4.5% or something, and that was a month or two ago. And now we just ran it on 01 and it gets 7%. So, and then I'll just talk about 2 other papers I recently wrote. So automated research has these 2 facets that I'm excited about. One is helping researchers do better research. So we wrote this data set called CiteMe that just asks questions about when the first time a certain scientific claim was made. So questions like when was the first paper to show that deep positional embedding is better than sinusoidal ones? And then you have to find me the paper that said that. I think the state of the art was like 30%, and then we wrote an agent. So that's another benchmark we have. And then this is the thing I told you guys about the restaurant thing. So it's called Assistant Bench. And we have a lot of these types of questions. Some of them get really complicated. One of our friends, I wrote this with a bunch of collaborators from Tel Aviv University, and one of our friends was going to London, and he wanted a suit tailored by a tailor who was a student of this specific person. Apparently that's a thing, and he wanted his tailor to be on a certain like part of London. And so, yeah, one of the questions there is, where can I get a suit tailored by somebody who was a student? These questions get very complicated, but they're all kind of realistic. And I mean, I ask this question all the time, and Google can't answer it. So we wrote this benchmark, and then we wrote an agent, and the agent achieves, again, like 20% accuracy. So I'm very excited to have more people working this stuff. Yeah, we can do a few questions now.
How does this verification?
It's just a list. It's just a list.
But that'll change
Yeah.
next year.
Oh, yeah. So a lot of these questions are going to change. So we kind of said that we want this benchmark to live for a year. We think it'll live for a year, and we don't really care about what happens in more than a year. Because from my experience, things get saturated in a year. I wrote this data set called Bambooga like 2 years ago, and it was questions that fool Google. And Google actually fixed it. Like those questions don't fool Google anymore because Google engineers actually, I know this, they told me, they went through question by question to make sure they fixed their answers to questions.
So your real purpose is to solve all of your life.
Yes, yeah. If you look at my data sets, there's a lot of things that I'm learning. Yes, of course. But anyways, what I've learned over the past few years is that data sets get kind of saturated within a year. You can also look historically like human event, other things. So when you design a data set, it's totally fine if it expires in a year. And I'd rather have a data set that's very natural and expires in a year, rather than have something very artificial and forever. Okay.
Okay, so we actually have one lightning talk, which we're starting on again this semester. It'll be super quick, and the first one happens to be me. I'm a fifth year PhD student for Karthik. So I'll quickly talk about this fun bug story that I was having in my one of my last projects where we were building an agent
I don't know.
for NetHack. So NetHack is this dungeon crawler. You're this like cat character agent. You have to like fight monsters, fight items, and the dungeon is defined through these like all ASCII characters. It's a pretty old game. Like, this is the 1980s. And so we were training an agent to play it. And someday something pretty unexpected happened. So we used to get 5,000 when we evaluated on the game. Next day we get 3,000. We're like, okay, that's a little weird, but you know, maybe a little bit annoying, but probably fine. Maybe I just, you know, something with the evaluation configurations was wrong. So I double checked that, but everything looks good. Maybe I sort of, you know, checkpoint was wrong. So I triple checked the checkpoints. I even re-download the one that I uploaded to the GitHub, but it's still getting a score of 3,000. Maybe the evaluation code changed, right? So maybe I sort of wrote in some buggy code. There were some logging changes. I checked the commit history, but those shouldn't really affect the score. I decided to revert anyway because I was kind of getting a little paranoid. And evaluate, it's still 3,000. So then, as any good machine learning scientist should do, you should look at data, visualize the model playing the game, just to see if anything's off. And you know, everything looks good. Like the model's playing it fine. Still 3,000. And so this is the point where I got a bit worried because I sort of done, I think, sort of the first sanity checks that everyone should be looking at. And so I started to think of more crazy reasons, like, oh, maybe my auto environment, or like it doesn't work on Della, or like my PyTorch version, or CUDA versions, or drivers that were updated. And so I look into all of that, but at the end of the day, it's still 3,000. And at this point, it's late, and maybe I just imagined my model getting like, maybe it was just always 3,000. So I go to sleep to hope for a fresh mind in the morning. And so the next morning, I decide to look one more time at like the model playing the game. And so I sort of get stuck on just the first frame in the game. And this is what a usual starting frame looks like. It says it just welcomes you to the game. So the message will be very important here and tells you kind of what role you are in. But today's starting frame of this new morning had almost the same message, but it had this like little more thing there. And I was like, okay, it's telling me, it wants to tell me a longer message this time. It says, you're lucky, it's a full moon tonight. And so I'm like, okay, this can't possibly be the reason for my bug. Like, I can't tell people that I had a model underperforming because of the moon phase. And then I look at the NetHack wiki and I found out, like, actually, no, in NetHack, the real world time data and moon phase all affect gameplay. Like, it could really be, and I even checked the data and it's telling me, like, yes, today it's a full moon. So it sort of checks out, but I'm still a little weirded out. But I decided to try it anyway. So I changed the NetHack source code to never give me a full moon. I evaluate them all. And I get 5,000. So bug fix. So there's a little tail to this story. A few months later, there were some collaborators in Poland who were using my model as well to do some reinforcement learning planting. And they reached out to me. Hey, I have a really and, you know, I started suspecting the CUDA version. I said, oh yes, that's probably a full moon. So actually, this friend of mine, Bartek, he had a really nice write-up of this story from his side of the story. So I'd recommend checking it out as well. I'll end with this slide that maybe, you know, sort of this should also say that NetHack is very complex and maybe even act as a benchmark for language models, or tying in a little bit with Ofir's talk. So this is what the current state looks like for NetHack. So here's the best human, note the scale here. And you might be waiting for me to plot the other models, but they're already on there. This is the gap. So they're around like 85,000 and 200,000. These are max scores, but best humans get like 20 billion. So it's a massive difference. And I'll end with this tweet from Tim Arteshel, who was like the founder, one of the founders of the NetHack benchmark. He was celebrating in June, I guess, the fourth year or fifth year that there's still not much progress on that act and sort of, reminding people of the gap. So just food for thought. Thank you.